Hello guys, welcome to Ask Raghulan. Today we're going to see a topic about civil engineering. So we have seen few videos based on education. So this is one of the things that you can watch. So in this video what I'm going to go through is if you are a civil engineer, the thing that you need to get yourself prepared for the future, which is coming from 2020. In the future, most of the civil engineers need to know about something called BIM. So what is BIM? So BIM is basically building information modeling. So that means if you're into building industry, and if you're into infrastructure, and if you're into rail and road projects, and some of these projects these days they have to be BIM compatible. Alright, so before we get into the video, so one thing I want to be clear, so this video is not going to be in depth into BIM, so it's not going to be a more technical video. So I'm going to do a bit more technical video under Expertisor Academy, so probably I'll add a link in the description, you can get there. So this is just an overview of BIM and what you need to do and what you need to know. So some of these basic things. Alright, so let's quickly run through what is BIM. So BIM is basically called as building information modeling. So when this is all started, so this started pretty early than most people really think of. So this actually started by 1986 by Simon Ruffalo, and he actually created a small white paper based on how we can collaborate in an engineering environment. So now if you see, if you're coming from a typical software or an IT background, you would obviously using a lot of tools such as, let's say, for source control you'll be using GitHub, and then for project management you'll be using some of the project management tools, and you see a lot of these tools that helps you to collaborate between different teams such as developers, testers, designers and stuff. So whereas with the engineering teams, if you look at it, typically in a standard construction industry, so you will have a project manager, and then there will be a site manager, and there will be a lot of guys who's working under the site manager. So if you see, like, most of the project management is done in the PMO, that's a project management office, and the work order comes from the PMO. That means it's a top to down approach, which is a traditional project management approach. So now with the latest industry standards, people need to be informed. That means any decisions that is actually taken on the project management side, any NCRs, that is any changes that is happening to the current scope of works, people need to know on the site. At the same time, there will be procurement people who will be getting materials and other logistics. So they need to know what is happening, what they need to get next for the upcoming days. And then there is project management guys who need to plan the schedules. And then there is site managers who need to plan their work schedules, which is actually on the site with respect to the current weather data which is in present, and then with the schedules of the guys that they have in hand. So it's it's more on the field stuff that happens in the engineering side compared to the other fields. So now what we have here is we call BIM. So this is not specifically for civil engineers. So if you are a mechanical engineer, if you are into plant design, so then it could also be used in plant design as well. So BIM is not just specifically for civil engineering alone. Since my background is civil engineering, I'm going to talk a bit more about civil engineering, but it can be applied to civil engineering and architecture pretty much. And if you see, like, BIM actually started implementing, a lot of companies started implementing BIM in architecture space first. So civil came pretty much in the last, and then plant engineering. So if you're into plant designs, then BIM is something you will come across quite a lot, and MEP and a lot of these HAVOC and a lot of these things you will see it quite often. Alright, so now let's get through this. And so BIM consists of different types of implementation. So in a nutshell, what it is different teams collaborating, and then they want the information in one single place, and then anyone who's working on it, they get the latest information. And this also creates a documentation for the future. So that means once your project is done, you're not going to waste all the efforts that you have done to create all the shop drawings and stuff. So you're not going to throw it away. So this will create a documentation for the future guys to maintain it, or for continuous operations, or for future upgrades. So that is what BIM is all about. So now if you look at a project, there is actually three typical phases that happens. So one is your design phase, another one is your build, which is your execution phase, and then your operate, which is your operations that happens day to day. So this is a typical 3-stage in a project life cycle. So now what is happening in the infrastructure industry is by 2050 we're gonna have 10 billion people on the planet. So that is pretty huge now, currently compared to 7.2 billion. So we're gonna add another 3 more billion onto our top of our population records. So now this would actually increase the demand for housing. So because one of the primary things that needs to be considered when when there is a lot of human beings coming in is shelter. So we need to build a lot of shelter. So now these shelters not going to be horizontal, probably to be multi-story. So a lot of these projects going to be around the world. So a lot of countries going to build a lot of projects. Now with a small pool of engineering companies, small pool of civil engineers, how are we going to accomplish this task? So how are we going to make things faster? How are we going to make things better? So that is what BIM is going to come into place. So now if you look at it, what we accomplish with BIM. So one thing we get it is intelligent modeling. So we can do more intelligent modeling, collaboration, simulation, and sequencing. That's basically what happens in each stage of the project. And then documentation that comes at the end of the project, and also during the due course of the execution of the project, which you can help to communicate between other people through means of documentation. So that is also very important in a project space. And then coordination. That's coordination is pretty much communication between different teams as well. This is in close relation to your collaboration segment of the project as well. So BIM delivers these features, not just that. So it also delivers few other things as well. So now what are the different types of BIM? So traditionally people started using 2D AutoCAD or any of the MicroStation products to create 2D floor plans of your building, and then they start constructing from that. So now we have evolved from that. Probably it's around 30 years ago. So now still people do use 2D design, so there is no harm in it, but still people these days use more 3D models. People use more collaborative models, and that comes in handy with some of these BIM implementation. So what we accomplish here is there is different types of BIM that we can implement. So one is a micro BIM, 3D, 4D, 5D, 6D, and 7D, different types of BIM. So this basically, as you choose your particular type of BIM, let's say if you take 3D BIM, if you look into the 3D BIM data, so it will have the XYZ. That means it's a 3D model, and you get the X coordinate, Y coordinate, Z coordinate for every object that you see on the screen. So this is your 3D BIM. Similarly, there are other types of BIM as well. Again, I will go through all of these in detail in the Expertisor Academy tutorial. So this is just an introduction. And then, so level of BIM. So what sort of level the project requirement states, because each project, when they want to implement BIM, so they also specify what is the level of BIM they want to implement onto the project. So now if you see, level 0 is basically 2D drafting. So that's what the traditional means of people creating 2D floor plans to implement a particular project. And then we got level 1, which is concept design and 2D drafting. So that's like they create a 3D model, but they're not going to use a 3D model for any of the design element or for the construction element. It's purely for conceptual design. So that is basically, if you see a render of your apartment, that's your construction company is going to build it, but the render is not going to be the exact representation of your apartment. It is just to give you an idea how it's going to look, what's the colors that's going to have, some of these basic elements. So that's a conceptual design. And then the level 2 BIM is basically including all the first 2 stages. This will have collaborative element as well. And then we got level 3, which will be adopting open data standards. I'll come to open data standards a little later. So that is a whole bunch of area that we need to address, because we've been like 30 years, a lot of companies, a lot of softwares, they've been evolving in their own life cycle. So now they are given a task that they need to work in a BIM space. So now they are scrambling around to find one unique way that is like a one common way that everyone can talk to each other. So which is what the challenging part of it. So now let's look into an building space. So what happens in a BIM environment? So if you see, like a typical building has got a whole bunch of engineering that goes in there. It's not just one civil engineer who can go and do every work. So there is lots of other engineering department that works together. To give you an idea, let's say if you got so we got a superstructure, which is your building, and then your substructure, which is your foundation, and anything that can under the structure, superstructure. So now if you go under the ground, the things that we need to know is what is the soil condition. So we need to do a soil test, and then what is actually the chemical composition of your soil, and what is the compaction of your soil. That means like how much load that your soil can hold. Because if you see, most of the large buildings that people build, they actually compact the soil quite heavily, in the sense that it's going to sustain the very huge heavy load coming from multi-story building for several years. So that is compaction. They want to make sure that the earth is consolidated, so it's not going to move anywhere after that. So that is compaction. So now so once we have the subsurface information, so that comes from the soil engineers. So they do the soil test, they give you all the data, and then it goes to the geotech. So geotech is basically, they want to see if the load comes in from the structure and what type of foundation that the engineer needs to implement for that structure to sustain. Because if you put a wrong foundation in, then the building's going to collapse, so which is something which you don't want it. So now what type of foundation that we're going to have. Sometimes people go for raft foundation if the soil conditions are pretty nice, and sometimes if the soil conditions are pretty loose, they might go for a pile foundation, which generally creates a sort of like a skid friction, and then it gives you more ability to take bigger loads in a poor soil conditions as well. And then this is actually the substructure. So once we're done with these ones, then we go to the superstructure. We have concrete slabs, columns, beams. So this is all comes from the structural engineers. So they're not civil engineers, they're actually structural engineers. That's another part of engineering, where they actually decide what sort of foundation they need to go, what is the thickness of the slab, and what sort of beam and what sort of concrete mix that they're going to use, and a lot of these things. So it comes from the structural engineers. And so once the structural engineers have done that, we got the floor plans from the civil engineers and the architects, and then we got the electrical layout from the electrical engineers, and then we got the air conditioning, which is heating and cooling, and then so we have roofing, and then we have something called smart home systems as well, which is the IoTs, Internet of Things. So if you see, like, simple home can have whole bunch of other things. If you include water, plumbing, hydraulics, a lot of those things. So if you see, it's a whole bunch of engineering that works together. So it's not just one engineer can do this work. So when different types of engineering departments work, they have their own software for designing, testing, and implementing. So when these softwares don't talk to each other, that's where the problem is, and that's where the communication gap is. So now what people do, they make mistakes. So when they make mistakes, then the project's not going to look exactly as what it was promised. So now, to avoid all that scenario, they're creating this BIM concept, so that way people can collaborate without much of a hassle. So now, once all of these guys see the data that is coming from different departments in one single piece, and they should be able to browse through different things and in a way that they will understand their data much better, and at the same time they also understand the other engineering department data in a common terminology terms, then it makes it easier. So that's what BIMs. So bringing all the data together, put it together, and make sure that all the different departments can talk to each other from a single point of system contact. So that is in a nutshell. So then, and also the new things that people are going to implement these days is the green building concept. So that's basically to make sure that how much is your carbon footprint for your building and how we can offset it. So those sort of things. And now open standards, there are a couple of standards which are pretty famous. So one is IFC, which is Industry Foundation Classes, and another one is COBie, which is basically sort of like an Excel sheet based template where you can manage the BIM data within that. So if you look at it, IFC is more graphical oriented. It's an ASCII XML sort of format where you can store all the 3D data as well as the attribute information. That is basically when you select a particular foundation, it tells you who designed it, what time it was designed, and how long it is valid, and what sort of foundation it's going to be, and everything. So you can store all those attribute information as well. COBie is very good for storing lots and lots of attribute information, but it's not going to have a lot of graphic data. It's going to have limited access to storing graphical data. So that is COBie. And then we got BS 1192 2007. So that's actually in standards, IS standards. And so this will for the common data environment for data exchange. And next, we got the process of BIM. So BIM has got a process. Now you see, this is your typical project life cycle. So this is your BIM process of how you accomplish BIM. So first is your plan, and that's basically you want to what you decided to do, what you're trying to execute, and what you're trying to deliver to the client. So which is your planning. Then you got your design, where you do your actual design, such as shop design, conceptual design, whichever the design goes in there. And then the build. So that's basically the execution part of it. So what are the documentation that you need to give it to the execution side of the project to execute the project to its success, and then they operate. So once it's all done, you need to give some information to the guys who is managing the facility. So that is the operations. So we need to give them some sort of a documentation. So BIM covers all these 4 portions. So now if you're a civil engineer, if you're a mechanical engineer, and if you want to know what are the softwares that you can learn which is also BIM compatible. Remember, BIM is not a software. BIM is a process. BIM is a concept. So there are softwares which will enable you to adopt BIM into your project, to implement BIM into your project. So some of these softwares vendors are Autodesk, Bentley, Graphisoft, and there are a whole bunch of other guys which also does BIM compatible projects. So now what all the projects that I have worked is in typically, I come from a civil infrastructure background. So civil 3D, InfraWorks, Revit, MEP, all these ones, they help you accomplish, deliver a BIM project. Similarly, if you go to Bentley, they got Open Roads, they got a whole bunch of other softwares which helps you to implement BIM deliveries as well. All right, guys, so that's in a nutshell what is a BIM. So if you're an engineer, so get through some stuff and then try to understand what BIM is and how we can work through in your next project implementing BIM. All right, thank you so much, guys. Thanks for watching, and have a good day. Cheers.